Assalamu alaikum and welcome to ninth lecture of Basic Statistics 2. As we know that we are studying about sampling and sampling distribution. In last lecture we have discussed the sampling distribution of the means, and now today our topic is sampling distribution of differences between means, and these means are of sample means. Now, when we have two large population with mean mu1 for first population and mu2 for second population, and variances sigma 1 square for first population and sigma 2 square for second population respectively, let independent random sample of size n1, small n1 and small n2 be selected from the respected populations, and the difference x bar 1 minus x bar 2 between the means of all possible pairs of samples be computed. Then the probability distribution of the differences which we will compute is called the sampling distribution of the differences of sample means. Now, this sampling distribution has also the two properties. First property is the mean of the sampling distribution of the differences between means, that is x bar 1 minus x bar 2 denoted by mu, and here we have x bar 1 minus x bar 2 is equal to the differences between the population means. And as it was discussed that first population has mu1 and second population has mean mu2, so the mean of the sampling distribution of differences will be equal to the original differences of the population means. It will be more clear to you when I am going to solve a question, so it will be more clear to you, but up till here this is enough. Then the second property is the standard deviation of the sampling distribution of means, of the difference between means denoted by sigma mu1 minus mu2 is given by sigma mu1 minus mu2 is equal to whole under root sigma 1 square divided by n1 and sigma 2 square divided by n2 when it is with replacement, and when the sampling is done without replacement we are going to use this formula. So now I am going to solve a question. This is question number 14.43 or 43 question from the book Introduction to Statistical Theory Part 2. So this is the first chapter of the second book, that is part 2. So you can now for this sampling we are going to use Introduction to Statistical Theory Part 2 book by Sher Mohammad Chaudhry. Now this question you can take from the exercise. So what this question says that let x bar 1 represent the mean of the sample of size and 1 is equal to 2 with replacement from the finite population. This population is given, first population is 3 4 5, and similarly x2 bar will represent the mean of the sample of size and 2 is equal to 2 with replacement from the population 1 1 3. Now, first of all, find the possible differences between the sample means of two populations. First, we'll find the differences, and then second part is construct the sampling distribution of these differences and compute its mean and variance and verify these two properties which we have discussed before. So now how to solve? First step is again the population, but here we have two populations, so we will write these two population. First population, here population 1 is 3 4 5 and population 2 is 1 1 3, and so n1, because here we will write n1 because we have two populations. So n1 is the size of first population, capital N2 is the size of second population. Both are of 3 3. And then in question it was mentioned that small n1 is also 2 and small n2 is also 2. So here I have written now number of possible samples with replacement. This WR shows the with replacement. So for formula for with replacement is n power n. So now 1 is written here because it is written here to distinguish. So here when we see that n1 power small n1, this is 3 power 2 which is equal to 9. So here are 9 samples, and similarly it is same for the second population. So now the sampling is with replacement. So first of all 3 can be replaced. So first sample is 3 3, then 3 4, then 3 5. Then when after 3 5 4 3 4 4 4 5, then 5 3 5 4 and 5 5. So here are all 9 samples for first population and 9 with the same method we have drawn the samples of second population. Now for the mean of first population it is represented by x bar 1 and the mean of second population is represented by x bar 2. So here I have computed means. 3 plus 3 is 6 divided by 2 is 3. So here I have calculated the means of first population and means of means of first samples and means of second samples. Now the second part was that first part was the find the possible differences between the sample means of the two population. So for this is in this method of differences, first of all we have to find differences. Now how we'll find differences? I have written here in the columns. I have written above all the columns I have written the values of x bar 1, and and here in this in this row, first row I have written the values of x bar 1, and in this first column I have written the values of x bar 2. Now we have to subtract the values of x bar 2 from x bar 1. So 3 minus 1 2, 3.5 minus 1 2.5, 4 minus 1 3, and like this we will compute all the differences, and here are 81 possible differences. So now sampling distribution for the differences. Now here I have written all the possible differences which I found in this table here. So now these possible differences: 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5 and 4. So these are possible differences, and then we write the frequency. And I have told you before that what is frequency? Frequency is the number of repetition. So here you can see from this 2 to 4 and then 2 0. These are all the differences. Whereas this first row and first column are the original mean value. So we will exclude these and we will just use this inner values which are the differences. So we will count that in how many times 0 occurs just one time, then 0.5 occurs two time, and so on. So I have told you before that when to check that whether our count is right or not, we have counted correctly or not. So we will add frequency, and if the frequency is equal to the total number of differences, which is 81, so your question is correct. So here it is equal to 81. Now probability, I have told you what is probability: number of occurrence divided by total. So number of occurrence of 0 is 1, so 1 by 81, then 2 by 81, and up to so on, and its answer will be its sum will always be 1. And then again for mean we have to compute this column, which is differences multiplied by probability of differences. So here we have to multiply this column with this column, so and we multiply this with 0. So first one is 0, then 0.5 multiplied by 2 is 1, and up to so on, and the final answer or sum of this column is 2.33. Next, last column is square of the differences. So square of the differences multiplied by probability of difference. So we will take square here, and then we will multiply with the probability. So you get this, and final answer is 6.22. Now, for the verification of properties, as we know, these are the properties. The mean of the sampling distribution is equal to the difference between the population means. So this is the mean of the mean of the sampling distribution of differences is equal to summation differences into P of differences. So here this column, this is the sum of this column, and it is 2.33. So here I have directly written 2.33. Now when I have computed first mu1 from the population, I have calculated mu1 from this population and mu2 from this population directly, and then I have found the difference. And when I found the difference is exactly the same, so this first property is verified. Now for second property, this is variance of the sampling distribution is equal to sigma 1 square divided by n1 plus sigma 2 square divided by n2. First of all, for left hand side, this sigma 1 is this sigma square of differences is equal to summation square of differences into p of x minus into p of differences minus summation differences into p of differences whole square. So this we have already got from the table. We get these both the values from this table. So the we take these values. Summation of this column is 6.22, and summation for this column is 2.33. So I have put the values here and found the answer, which is equal to 0.79. Now for this sigma 1 square, I have calculated this. I have written here directly because in last lecture I have discussed this in detail. So if you again listen to this last lecture or eighth lecture, so you will get in detail, or if you study in the book, it is more clear to you. Okay, now I have taken directly the values, calculated directly the values, and I have put in right hand side. So look, here is the final answer is 0.778 or 0.79. When we'll round off this, these are approximately equal, and the second property is also verified. So this is all for today. Now two topics for sampling are left, and then after that we'll start our last chapter. Thank you so much.